Friction. Now, according to Newton's laws of motion, a body moving uniformly along a straight line would continue to do so unless an external force is applied on it. In practice, we find these things otherwise. For example, a ball rolling over the floor stops after some time. Similarly, when we stop paddling our bicycle, it comes to rest after traveling a certain distance. Again, when we switch off the engine of our car, it stops after traveling some distance. All these examples shows that there is some invisible force, basically the force which is actually opposing all these motions, that opposes the motion of one body over the other. This opposing force is known as the friction. Now, again, when we apply a small force on a block, it does not move. The applied force must have been balanced by the opposing force, means the friction force. Now, here we are talking about a big object. Like suppose you can consider the block to be of 500 kg and you are trying to move it, but it is not moving. So, there is an opposing force. Thus, a force of friction comes into play even when the body, when we tries to move. Thus, the applied force must have been balanced by the opposing force. Thus, the force of motion comes into play even when one body tries to move over the surface of other. So, basically, we define a friction like friction is an opposing force that comes into play when one body actually moves, slides or rolls, or even tries to move over the surface of another body. If the force, now it is the force that develops at the surface of contact of two bodies and opposes their relative motion. Now see this diagram. Now consider a block of weight mg. This is the block whose weight is mg, is lying on the floor. R is the normal reaction. Now when a body presses against the surface deforms. So basically it is pressing against the surface and the surface deforms even if appears to be rigid. The deformed surface pushes on the body with a normal force R. This is perpendicular to the surface. This is called the normal reaction, which basically balances mg. So basically this is the weight of the block and this is the normal reaction. Now suppose this is the applied force, means you are applying a force. A small force is applied on the block to the right. As you can see, the force of friction will act always in the opposite direction. So it is acting in the opposite direction. It opposes the motion. As long as the block does not move, it opposes the motion. So basically in this case, if we take P to be the applied force, the forces that you are applying to be P, so in this case F is equals to P. F is what? The force of friction. P is the applied force. So these two forces are equal. This means that as we increase P, friction F also increases and remaining equals to P always. So this is what the static friction is when the body is actually not moving. So the opposing force that comes into play when one body tends to move over the surface of another, but the actual motion has not yet started, is called the static friction. Now, again from this diagram, this is the case of static friction. The magnitude of static friction is not constant. It always adjusts itself so as to be equal to the applied force. Now, consider the case. Now, if we increase the applied force, you know that a stage comes when the body is at the verge of moving over the other body. That means it is just about to move, but is not moving. The static friction at this stage is obviously maximum. This maximum value of static friction is called a limiting friction. So a limiting friction is the maximum opposing force that comes into play when one body is just at the verge of moving over the surface of the other body. That is called the limiting friction. Now, when we increase the applied force, when we increase the applied force slightly beyond limiting friction, the actual motion starts. This does not mean that the friction has disappeared. It only means that the applied force is now greater than the force of limiting friction. That's because of this only the block is moving. The force of friction at this stage is known as kinetic friction or dynamic friction. So it's kinetic or dynamic friction. So kinetic friction is the opposing force that comes into play when one body is actually moving over the surface of another body. So that is the kinetic friction. Now there is a point to note. So this is the point to note actually. Kinetic or dynamic friction is always slightly less than the limiting friction. Now see, this is because once the motion starts, actually the inertia of rest has been overcome. Also, when motion has actually started, irregularities of one surface have little time to get locked against into the irregularities of other surface, which is the basic cause of this friction. Now, dynamic friction or kinetic friction is of two types. So one is known as the sliding friction. Now the opposing force, now sliding friction when the bodies are sliding. The opposing force that comes into play when one body is actually sliding over the surface of other body is called a sliding friction. Okay. Now the second part is the rolling friction. The opposing force that comes into play when one body is actually rolling over the surface of another body is called a rolling friction. So these two are examples of kinetic or dynamic friction. Sliding friction and rolling friction. Now one point, again a point to note is that rolling friction is often quite small as compared to the sliding friction. Now why? Because the velocity of, now see, if you consider the wheel which is rolling on the surface, the velocity of point of contact on the wheel with respect to the floor, that wheel which is rolling on the floor, so the velocity of point of contact of the wheel with respect to the floor remains zero at all time, although the center of the wheel moves forward. Therefore rolling friction is quite small as compared to the sliding friction. Now that is that is why heavy loads are transported by placing them on carts with wheels. The sliding friction is converted into rolling friction. Now for example, just for the idea, the rolling friction of steel on steel is hardly 1%. So means rolling steel on steel is hardly 1% of sliding friction of steel on steel. So basically rolling friction, when we roll steel on a steel, that is just 1% when we slide steel on steel. So that is the difference. Now the next point is, okay, coefficient of friction. Now we know that the limiting friction is directly proportional to the normal reaction. That that limiting friction is directly proportional to normal reaction, and this F is equals to mu r, or you can write mu is equals to F by r, where this mu is the constant of proportionality and is called the coefficient of limiting friction between the two surfaces in contact. Mu is F by r. Now the coefficient of limiting friction between any two surfaces in contact is defined as the ratio of forces of limiting friction and the normal reaction between them. This is limiting friction and this is the normal reaction between them. One more point, mu has no units. So mu has no units because it's a ratio, so it has no units. Now when a body is actually moving over the surface of another body, we replace this limiting friction F by Fk and the kinetic friction mu by mu k, so that the equation that becomes mu k is Fk by r. Now mu k is what? Coefficient of kinetic friction when the one body is sliding over the surface of another body. Fk is the coefficient of Fk is the kinetic or dynamic friction, force of kinetic or dynamic friction. R is the normal reaction. Mu k is the coefficient of kinetic friction or dynamic friction. Now we know that Fk is less than F. We have discussed that Fk means the kinetic friction is bit less than the static friction. Therefore mu k is less than mu. Mu k is always less than mu, that is the coefficient of this dynamic friction. is always less than the coefficient of limiting. Sorry, coefficient of kinetic friction is less than the coefficient of limiting friction. Now, the angle of friction. Now see, before going to this, see the diagram. Now this OA, now this is, you can see this is a surface, this is a block kept on the surface. OA represents the normal reaction. This OA actually is the normal reaction. This is the weight mg. This is the applied force P towards right and on. It's obvious that force of friction will act opposite. So this is the force of friction. Now OC is what? OC is the resultant of this force of friction and the normal reaction. And what is angle of friction? Angle of friction, this is theta, is known as angle of friction. This is the angle between the normal reaction and the resultant of the frictional force and the normal reaction, that is OC. So this is angle of friction. So the angle which the resultant of force of limiting friction F and the normal reaction R makes with the direction of normal reaction R. This is known as the theta. Now, our next point. Relation between mu and theta. So relation between the coefficient of friction and the angle of friction. Now see in triangle AOC. Now if you see, this triangle AOC, what is tan theta? Tan theta will be AC by OA. Okay, tan theta is AC by OA. Now what is AC? This AC can be replaced by this thing. If you take this point, okay, we can take this point as B, such that you can draw this line. Actually, this, you can say this as a parallelogram, or a it's actually a parallelogram only. We cannot say this to be a rectangle because this will be 90 degree then, but it's a parallelogram. So we see that AC is equals OB. So we have replaced AC by OB, so this becomes OB by OA. Now what is OB? OB is this force of friction. OB is this force of friction, and OA we can replace this by normal reaction. So this is F by R. But what is F by R? Is equals to mu, because we have done this. Mu is F by R, so we have changed F by R to mu. So what is mu? Is tan theta. This mu is tan theta. That is the coefficient of limiting friction between any two surfaces in contact is equals to the tangent of the angle of friction between them. Now, the angle of repose or the angle of sliding. First of all, it is denoted by alpha. The angle of repose or angle of sliding is defined as the minimum angle of inclination of a plane with the horizontal such that the body placed on the plane just begins to slides down. So this is an example. So now you see, this is an inclined plane, this is alpha. Now this alpha is what? We can say this alpha is the angle of repose or the angle of sliding. See the forces. Now this block mg is acting vertically downward. Now if this is alpha, this angle is alpha. So we can resolve mg as mg cos alpha and mg sin alpha. And this is the force of friction because this is about to slide. Now, so we see that this force of friction is equals to mg sin theta, and normal reaction is a force of friction is mg sin alpha, and normal reaction is mg cos alpha. Okay, so now, so this is a force of friction is mg sin alpha, R is mg cos alpha, F is mg sin alpha, R is mg cos alpha. Now see, taking this as equation 1 and equation 2 and dividing 1 by 2, we get F by R is mg sin alpha by mg cos alpha. Mg will get cancelled, sin alpha by cos alpha is tan alpha. So basically what is mu? Mu is tan alpha, and we know that mu is tan theta, which is equals to tan alpha. So what is theta is equals to alpha, that is the angle of friction, that equals to the angle of repose. Now moving on to questions. The first question is, find the distance traveled by a body before coming to rest if it is moving with the speed of 10 meters per second is moving with the speed 10 meters per second, and the coefficient of friction between the ground and the body is 0.4. So they have given you 0.4, the coefficient of friction between the ground and the body. Now first of all, we will start writing what is given to us. First of all, in this case, we have to find S. S is what? We have to find the displacement. Find displacement. We know that the final velocity is 0 because it is coming to rest, and the initial velocity is how much? 10 meter per second is the initial velocity, and also the coefficient of friction which is mu actually is 0.4. We know that by the formula mu is equals to F by R. So what is F? F is the force. We can write this as, so F by R, I'm sorry for this overwriting. So F by R is equals to M A, and R is M into G. So you're cancelling these M, we get A by G. So basically what is mu? Mu is actually A by G. From this we can find A. What is A? A will be mu times G. So substituting the values, mu is how much? 0.4, this is 9.8. So this is, acceleration is 3.92 meter per second square. This is the acceleration. Now we have to find the distance also. Now using the third equation of motion, v square minus u square equals to as. Now substituting the value, 0 minus 10 whole square equals 2 into, this is minus 3.92, because this is the retarding force, means this is the force of friction, so it will oppose the motion, into S the displacement. So this will be minus 100 upon, this is minus 2 into 3.92 equals S. Now solving this, S is what? 12.75 meter. So this is the displacement of the block. Next example. A block A of mass 4 kg is placed on another block B of mass 5 kg, and the block B rests on a smooth horizontal table. Okay, so you can see this. This is actually block A, block B. This is 4 kg, this is 5 kg, and this B rests on a smooth horizontal table. So that's a smooth horizontal table. For sliding block A on B, a horizontal force of 12 Newton is required to be applied on A. So basically, if you want to slide A on B, you require at least a force of 12 Newton. Now the question is, how much maximum force can be applied on B? So this force we have to find, which can be applied on the B, so that both A and B move together. Also find out acceleration produced by this force. Now that is the question. So first of all, what is given to us here? See, what is M1? M1 is 4 kg, which is the block A. M2 is 5 kg, which is the block B. The force applied on A. Now the force applied on this is 4 kg, this is 5 kg, this rests on a smooth horizontal surface. Force applied on A is how much? The force which is applied on this is 12 Newton. So force applied on A, let this force is 12 Newton. Now see, 12 Newton means this is the force for which actually, this will start sliding on this, on B. So this must be at least equal to the force of kinetic friction applied on A by B. So basically we can find the kinetic friction between these two, because we don't have to find this thing because this is smooth horizontal surface. So you have to find mu k between these two surfaces. So F is what? This F is actually equals to Fk, which is equals to mu k into R. So Fk is how much? This is 12. We can find mu k. Now R is what? R is m1g. The normal reaction R, m1g. So m1 is how much? 4. So 12 by 4g equals mu k, or this is equals to 3 by g. So this mu k is basically equals to 3 by g. Okay. Now as the block B, you can see block B is on smooth horizontal surface. Therefore, to move A and B together means this is a force, and they will move together because of the friction between these two surfaces. The force F required to be applied on B, this required, is equal to the frictional force applied on A by B plus the frictional force applied on B by A. So the force is given as, the force will be C mu k m1g frictional force plus mu k m2g. Now we have the value of mu k, so you can take mu k common mu k common as well as g common. This is m1 plus m2 g. Now this will give you the value of 4, so this is equal to mu k is actually 3 by g, m1 and m2 is 4 plus 5 into g, g and g will get cancelled, so this is 9 into 3 is 27 Newton. Now 27 Newton is the force with which you can apply so that these two will move together. Now you have to find the acceleration. See, since both bodies are moving together, so acceleration is basically force upon m1 plus m2. This is equals to actually 27 upon m1 plus m2, give you 4 plus 5, which is 9. 27 by 9 is 3 meter per second square. Next example. A block of mass 10 kg, now see 10 kg, is sliding on a surface inclined at an angle of 30 degree. So it is already sliding on a surface inclined at an angle of 30 degree with the horizontal. Calculate the acceleration of the block. So you have to calculate acceleration, and what is given is the coefficient of kinetic friction between the block and the surface is 0.5. So see, this is actually the diagram. Okay, now this is the block which is sliding. Theta is the angle of this inclined plane with the horizontal. Now see, mg is acting vertically downward. So we can resolve mg as mg cos theta, mg sin theta. So this is what? The force of friction. This is the normal reaction, and it is already sliding down. So now when this block is sliding down with some acceleration, so that means that this mg sin theta is more than this f. So the net force acting on the block is how much? The net force acting on the block is mg sin theta minus f. This is equals to m into a. Okay, the net force on the block is actually mg sin theta minus f. F is what? Is the force of friction. Now we know that what is f? F is mu r, the force of friction, mu r. So mg sin theta minus mu r equals ma. Now we know that what is r. Now r here is mg cos theta. R here is mg cos theta. So this is mg sin theta minus mu, and this is mg cos theta equals ma. Okay, so from this we can take mg common. So taking mg common, this will be sin theta minus mu cos theta equals ma. M will get cancelled. Now what is a? A is actually, this is equals to g of sin theta minus mu cos theta. Now substituting the values of what? This is 9.8. Now theta is 30 degree given, sin 30 is 0.5, minus mu is 0.5 given to you, cos 30 is actually root 3 by 2, which is 0.866. Okay, now solving all this, you get 0.657 meter per second square, the value of acceleration. So this a is equals to this.